Hello everybody, my name is Craig Bennett and I'm the founder and owner of TechFuseNelp, and today I'm doing the first video for CCNA, and basically this is to help you get your CCNA, and also I'm studying for mine, so I figured why not, and that way I can review some of these videos and do a quick thing before I take mine. Now, real quick, what is a CCNA, or was it good for? It's basically the starter level for working on Cisco networking equipment. And if you don't have it, then, in fact, if you get hired by Cisco and you don't have it, then you will quickly get walked out the door if you don't get it shortly. Like, they literally say 15 days or something like that. That never changes every so often, but you get walked out the door if you don't get it. So it's pretty important to get it before you even get the job and go for that. Now, one thing I want to mention right now is depending on what you're doing, is depending on if this is necessary. This is not an easy thing to get into, and it can take a lot of time and a lot of effort. But anyways, in order to go further with the Cisco certifications, you have to add the CCNA, and then it builds on from there. Let's jump into a quick personal advertisement, and then let's start our first Cisco networking, or CCNA class. If you would like to support us at TechFuseNelp, then please do one or all of the following. What you can do is you can select the TechFuseNelp logo at the top, and this will take you to our TechFuseNelp YouTube page, or you can select the PayPal button, and that will take you to our PayPal donation page, or you can select the Patreon campaign button, and that'll take you to our Patreon campaign. Now, saying that if you don't have the financial means, or you already done that, or whatever it may be, and you don't want to do that, but you still want to support us, you can also do some of the following. You can leave a like and share this video and any other video that you want from us, and maybe even our channel, and tell people why you like us, so other people could come and enjoy this and also help build up this community. You can also, if you like to help us but you dislike a certain video for whatever reason, go ahead and leave a dislike, but tell us what you don't like about it so we can fix it in the future. And also, as always, please feel free to subscribe and check out our other videos. And when you're checking out our videos, if you really want to support us, just go ahead and drop the ad blockers, and that way we can get our revenue. But if you want to continue to use your ad blockers, then feel free to do so. It's not like I'm not doing it. Welcome back. Now, as far as things goes, since this is our first go around, mentioned that there is some prerequisites that is needed for you to understand what I'm talking about, because this is not a entry-level thing. Even though this is an entry-level networking, just to get to this point, you got to know a bit about a computer. So if you're trying to learn how Windows works, how to make a computer, how to do things like that, this is not going to help you. In fact, in many cases, you would be so behind the curve that you probably will end up just giving up and walking away. I do have videos on how to work with Windows, how to work with all this other stuff, so feel free to check that out. And if I don't have something in particular that you're looking for, and you can't find it on the internet, so keep in mind I'm not the only one who makes videos, but if you can't find it, then feel free to just tell me, and I'll try to take a look and see if I can make one real quick for you. But for the most part, you need to know how to work Windows. You need to know how to work some basic stuff on computers. Now, as far as things goes, this is a basic setup, and you'll probably see a similar setup at your own house. And by the way, one thing I will use out through these classes is Packet Tracer. It's a very good example tool. Instead of me having to rig up my own network, I can just do it on here and show you a little bit more than I can do on my own network. So as far as things goes, you'll find a similar network in most houses to this. So you have the internet, a cable or DSL modem, some type of wireless access points if the PC is just not connected directly into the modem. And if you got a wireless access point, you might have some phones, maybe a tablet or laptop or whatever it may be off the side. And you got you tend to have a PC or something plugged directly into the router, not always. But the important thing to get out of this is the actual IP addresses, is what is called IP addresses. So what is an IP address? An IP address is basically these, and each device has an IP address. Now what you're looking at is IPv4, and if you're dealing with the CCNA, then you're going to need to know what an IPv6, which we're going to cover in a second. But you're going to experience more IPv4 in real life and possibly on tests. But one thing that you got to keep in mind is each device has its own IP address. Now, not all devices have an IPv6 address, and the reason why is some devices just don't support IPv6. They're too old for it, or weren't built for it. But pretty much most new devices are built for it and can stand it. Now, what's the difference between IPv4 versus 6? The difference, to summarize it, is other than the 6 uses hashtags and all the other stuff, where 4 uses these numbers. The biggest difference is 4 is limited. Back in the day when 4 was made, it was pretty much could have a IP address. All the devices that was connected to the net at the time can have an IP address. There's been so many devices that's connected to the internet and just connected in general that have an IP addresses. IPv4 addresses, you're going to have some type of repeat into it. And this also includes in some MAC addresses. I've heard of scenarios where there's starting to become some problem with that in the next 5-10 years, where you're starting to have a repeat in the addresses itself. So to solve this, some smart guys, they basically made IPv6, but what's being used today is a IPv4 address and 6 for internal. And what I mean by internal is pretty much everything inside the house network or business network and anything like that. But once it leaves, say, a building, then it goes into the external and gives an entire different address. So example with here is the address coming in is just a bunch of zeros. It would never be zeros coming in. If you see that, you got a problem. But let's just say for the hypothetical situation, you got a bunch of zeros coming into, and this is your external IP address. This is what's linking you up from your internet provider to your modem. Well, when it hits your router, or some modems will do this, not more than not. If you get a modem from internet provider, it probably won't do this. But the router, it will have a it'll basically set the IP address to an internal IP, and then it will set it to something like 192.168.1.1, or in this case it's 0.1. And if you have your computer set up right, they will ask the router for an IP address, or they'll actually make up their own IP address, and they'll actually go and tell the router, this is my IP address. So what will happen is when the computers ask the router for an IP address, the router just makes one up, sends it back, and that's that. So, until the device resets or whatever, that's gonna be its IP address, and that's that. And as far as IP addresses, from there, as you may notice, this is 192.168.0.100. This is 0.0.101. You don't want these to be the same, and as you may guess, again, IP addresses are pretty much addresses, and it's like in real life. Let's say that you got a mail system, you got your local area, your region, maybe your country, your city, your street, your actual address, your number. Well, let's say that someone has the exact same thing. Your mail's going to get mixed up with theirs, their mail's going to get mixed up with yours, and no one wants that. So you want to have each individual location its own little address in real life, and same thing with here. You want each device to have its own address. There's also something called collisions. You could potentially experience this with the having multiple devices with the same IP address. But this might be a little bit confusing to you. So why is it that one side of the router has a completely different set of IP address versus the other side? And the reason for that is it's on a completely different network. The point of the router, and this is very important to note, the point of the router is to pass traffic from one network to a different network. Now, with a router, you can say, for example, if I want this PC to communicate with the laptop, I can do that. But the point of the router is to have the information go from one network to a different network. Now, there is something else, and it's called a MAC address. Again, I talked about this a second ago. And MAC addresses are different than IP addresses in a couple ways. IP addresses, they can be assigned to the device by the router or the server, but they can also be stacked. They can basically tell everything that I'm just going to keep this. And one thing to keep in mind is if something else on the same network has that same IP address, you can still keep that one IP address. But a MAC address, it's supposed to be different from any other device in the world. It's supposed to be is a keyword, but unlike a IP address where you can change it and go all over the place, a MAC address, it's burnt on the network card. So unless if you spoof the MAC address, which doesn't have too much to do with the CCNA, but unless if you spoof the MAC address, then that's that. But if you do everything legitimately, the biggest difference is you cannot change the MAC address again unless you spoof it, which in many cases is illegal. And by the way, the MAC address is known as the physical address. So a good way to think of this is think of, and by the way, on the right side of that thing that just popped up, that's what a MAC address looks like, and you can pretty much see what an IP address looks like and all the other stuff. But a good way to think about it is when you're born in the United States and some other countries, you usually have some type of identifier, Social Security or something else like that, that identifies you for all your life. In the United States, it's so you can pay taxes, and that shouldn't change. Again, you can spoof the MAC address just like you can spoof your social, but it's illegal in many cases, just like in real life if you spoof your social. But for the most part, if you do everything legitimately, in fact, if you do everything legitimately, the MAC address shouldn't change at all, and that's the important thing. So the MAC address sticks with the device itself. However, the IP address, the 192.168.0. whatever, it will change depending on the request from the device, the availability, and everything else. So while the MAC address is like the Social Security, the IP is like the actual address. So you might be moved around hundreds and hundreds of times, and that address, just like the IP address, it changes every so often. But that MAC address, just like your Social Security, always stays the same. So that's a pretty much a good way to think about it. But anyways, that's pretty much as far as I'm going to go in this particular video. I'm going to get more into some of the stuff. I'm especially going to get more into IP addresses when I talk about the difference between IPv4 and IPv6. In case if you're wondering in between time, the biggest thing to keep in mind is they're practically the same. It's just, does the router and the device itself support it? If they do, then you're not going to really notice too much of a difference. I prefer to stick with IPv4 if it's internal, and the reason for that is if you're working a home wireless network, then usually you can't run too many devices. Mine, I got a Nighthawk, which is one of the best, if not the best, wireless routers you can get to date. And on each band you can only run 32 devices, so I prefer to do IPv4 because you ain't going to run out of that, at least if you do everything right. So that's something to keep in mind, and I'll get more into this in later videos. But if you got any tips or tricks, leave them down below. If you got any questions, feel free to leave them down below in the comment section, and I'll try to get back to you as quickly as possible. Now, if you like this, then please leave a like, please subscribe, and please share. And please feel free to check out my Patreon campaign and the PayPal donation and TechFusion help. Also, please feel free to check out my other videos. But if you didn't like this video, then feel free to leave a dislike, but tell me why, and that way I can fix it in future videos. Again, it's been Craig Bent, the founder and owner of TechFusion Help, and please feel free to check out my other videos, and I hope you have a great day.